In 2019, a Chinese rover stumbled upon something on the far side of the moon. What they found wasn't just strange, it was potentially, but instead of celebration, there was silence. No press release, no transparency, just quiet, calculated secrecy. Why? And what does this mean for the future of Earth's energy? Let's uncover the truth behind the moon's most valuable secret. Chapter 1. The quiet race for lunar energy. Let's start with a simple question: why? Is everyone suddenly obsessed with the moon again? For decades, lunar missions felt like history. The Apollo landings became museum exhibits. NASA shifted focus. Other countries were too busy catching up with Earth's problems, and for the most part, the moon just waited. Countries are going back to the moon, but not to plant flags or take pictures. That's where solar winds have deposited higher concentrations of helium-3 over billions of years. Just months later, reports began to surface, whispers, really about a strange discovery. And when they did, details were limited. No deep analysis, no follow-up explanation, just a few statements and then silence. Because when a country finds something groundbreaking on the moon and Dawson T shouted from the rooftops, people start asking questions. Was it a byproduct of helium-3 concentration, a marker of past activity, or, worse, something they don't want the world to know? A shiny, glassy patch in the lunar soil. Scientists speculated. Was it melted rock, lunar glass, or something else? It could change the global energy market. Whoever controls it controls the future. It's also where fewer countries have explored, and it's much easier to keep things quiet. No radioactive waste, no meltdowns, just pure energy from atoms fusing together, the same process that powers the sun, and the mining infrastructure, while the rest of the world is still arguing over budgets. That's not science fiction. That's geopolitics. And the moon may hold over 1 million metric tons of helium-3, enough to power Earth for thousands of years. Because once someone figures out how to mine helium-3 from the moon and bring it back to Earth, they change the game completely. It's a light isotope of helium, rare on Earth but surprisingly abundant on the moon. While NASA has talked about it, and other space agencies have taken notice, China has moved quietly, strategically, and without a lot of media attention. We'll look at the science of helium-3, why it's so rare on Earth, and why the moon might be the only place we can get it. But more importantly, we'll explore the possibilities and the risks of a moon-powered future. Why is that important? Because helium-3 has the potential to fuel clean, safe, and nearly limitless nuclear fusion energy, the kind of power humanity has only dreamed of. This time, it's about resources, and there's one resource in particular that's caught everyone's attention: precise landings, sample return goals, soil composition analysis, and lately, a surge in patents related to helium-3 extraction and fusion. Until now, in recent years, something has changed, not just in science, but in silence. You might have heard the name tossed around in sci-fi stories, but helium-3 is real. Now, here's where it gets interesting. In 2004, China launched its Chang'e lunar program. At first glance, it looked like a standard scientific effort: orbiters, landers, rovers. But if you read between the lines, something else emerges. China wasn't just mapping the moon or studying its surface. They were analyzing the distribution of helium-3, where it's buried, how deep, and how much it would take to extract it. Not a coincidence that Chang'e missions focused heavily on the moon's far side, the part we never see from Earth. In 2019, China landed the Yutu-2 rover in the South Pole Aitken Basin, one of the oldest, deepest craters on the moon. Here's the twist. Chinese authorities didn't release higher-resolution images right away. This silence, more than the discovery itself, raised eyebrows. What was it, really? You might think this sounds paranoid, but remember, space is no longer just science, it's strategy. Helium-3 is not just another element. Fusion energy using helium-3 would be cleaner than anything we use today. Now imagine being the first country to get there, to claim a site, to quietly build the tech in China. For all its secrecy, seems to be one step ahead. The global media barely covers these missions. But if you follow the Chinese language releases, or dig through the technical papers published by their space agency, a pattern emerges. It's not hard to connect the dots. While other countries are sending astronauts and building lunar gateways, China is making moves on resources, the kind that reshape power, not just space. And here's the most unsettling part. No one's really talking about it. It's not on the front page. It's not in the headlines. But behind closed doors, space agencies and governments are paying attention. So the next time you hear about a routine Chinese lunar mission, ask yourself, what are they really looking for? And what have they already found? In the next chapter, we'll go deeper. Chapter 2. Helium-3. The fuel of the future. Let's talk about Helium-3. It sounds like something from a sci-fi novel, but it's very real. Helium-3 is a rare isotope of helium. Unlike the regular helium we use in balloons, Helium-3 has 2 protons and only 1 neutron, sometimes toxic, sometimes deadly. But Helium-3 offers something different. It can be used in nuclear fusion. That's the same process that powers the sun. 2 atoms collide, fuse into one, and release massive amounts of clean energy. That tiny difference makes it incredibly valuable. Why? Because it could change everything we know about energy. It's produced in tiny amounts through radioactive decay and is mostly used in advanced science experiments. Earth's supply is so limited that we can even test fusion reactors at full scale using helium-3. Among those particles is helium-3. Unlike Earth, the Moon doesn't have a magnetic field or a thick atmosphere to block the wind, so those helium-3 particles have been embedding themselves into the lunar soil, especially in the upper layers. Most of the power we use today, coal, gas, even nuclear, creates waste. That is enough to supply Earth with clean energy for thousands of years. And though official statements are vague, several Chinese research papers hint at active helium-3 analysis. Some missions even seem designed specifically to test extraction, conditions, temperature, pressure, soil, texture. Every step looks like part of a long game. The language is technical, cautious, but the intent is clear. They're not just exploring, but China is the one building actual missions around it. They're funding research, filing patents, training engineers, quietly laying the groundwork while the rest of the world debates. Not decades. That kind of potential is hard to ignore. They're looking for something, and it's not just science, they're thinking ahead. They know what Helium-3 could mean for the future. Energy independence, global influence, technological leadership. Announcing a plan to dominate Helium-3 mining might trigger resistance. It might spark legal debates or political backlash. But moving quietly, that keeps options open. According to current international space law, no country can own parts of the Moon. Quietly, but it got people talking, and more importantly, it fit the pattern, a pattern of targeted exploration, resource mapping, and strategic silence, silently, and perhaps deliberately. But what about mining rights? What if a country sets up a permanent base and begins extraction? Who's going to stop them? What's amazing about helium-3 fusion is that it doesn't produce dangerous radiation like other nuclear fuels. And what are the possible explanations? Some are scientific, some not so much, but all of them point to one thing. There is more going on up there than we're being told. Fast if China unlocks fusion energy first, powered by helium-3 from the Moon. The balance of energy on Earth changes overnight. Fossil fuels become obsolete. Nations dependent on oil and gas lose leverage. And whoever controls helium-3 becomes the new energy superpower. No meltdown risk. No radioactive byproducts, just pure, safe energy. In theory, a few tons of helium-3 could power an entire country for a year. And the best part, it's clean. It doesn't pollute. No smoke, no carbon. So why aren't we using it already? Because here on Earth, helium-3 is almost impossible to find. But on the Moon, it's a different story. For billions of years, the Moon has been exposed to the solar wind streams of charged particles from the Sun. According to estimates, the Moon holds over 1 million metric tons of helium-3. This is where China comes back into the picture. Their lunar missions aren't just about exploring the surface or testing technology. China's change missions have already brought back lunar samples. Those samples are being studied for helium-3 content, while other nations are still planning future trips. China is already mapping out where the helium-3 is, how deep it lies, and how to get it out. And here's the catch. No one else is doing this at the same level. The US has discussed helium-3, Russia, India, even private companies have mentioned it. Why the secrecy? Why not announce it proudly? Because if helium-3 is as valuable as it seems, then it's not just a scientific resource, it's a strategic asset. And once the technology is ready, it's too late for others to catch up. There's also a legal gray zone. These are questions that haven't been answered yet, but they're coming. Because helium-3 isn't just an energy source, it's a power shift. That's the future we're heading toward. So the shiny patch found by the U-2 rover, maybe it was just a curiosity. Maybe it wasn't. In the next chapter, we'll look at that specific discovery, the shiny patch found in 2019. Why did China hold back images? Chapter 3. The shiny patch on the far side in early 2019. Something unusual happened on the far side of the moon. China's U-2 rover was rolling slowly across the lunar surface, part of the Change 4 mission. It was the first mission ever to land softly on the moon's far side, the hemisphere we never see from Earth. Something shiny. In the middle of the dull, dusty lunar landscape, there was a patch of ground that looked different. It didn't match the surrounding soil. It wasn't the usual gray. It was glossy, almost glass-like. It reflected light. That area had never been explored directly, and many believed it might hold secrets hidden from human view for billions of years. It doesn't have weather, no water, no ice in that region. Nothing should look like gel. Was it a natural material? Something melted? Or was it something artificial? And yet, there it was, an unexpected surface anomaly right in front of the rover. On one of its slow daily treks, U-2 came across something strange. The moon is constantly bombarded by and with no atmosphere to slow them down, even small rocks can hit hard enough to melt the surface. But here's the thing, lunar impact glass has been seen before. Maybe it was older material, preserved for millions of years underground, only recently exposed to sunlight. That might explain the odd texture. But again, this doesn't fully account for the shine or the silence. It doesn't usually look gel-like. It's usually rough, fractured, and scattered. Not smooth, not patch-like, not necessarily a structure, but maybe a residue. A material not formed naturally, something that doesn't belong. Chinese scientists referred to it cryptically as a gel-like substance. That alone raised eyebrows. The moon, after all, is bone dry. Just a vague mention in a Chinese language mission report, which was later picked up by amateur space trackers, especially when something unusual shows up. NASA, ESA, even private companies publish quickly, often within days. But with U-2, the delay was measured in weeks, and even then, the information that did come out was vague. The term gel-like substance quickly made headlines around the world, but with no real follow-up. But the reflective patch was visible. It stood out against the regular and that was enough to ignite the internet. What was even more curious was how the data was handled. But the shiny patch remains the most talked about, because it doesn't fit. If so, that would make it a priority site for future missions, a natural reservoir of fusion fuel, sitting just below the surface. But one thing is clear, it sparked global interest in a quiet mission no one expected much from. Because this isn't just about one shiny object. It's about a pattern of missions, each revealing a little more, each step carefully planned. The bigger question isn't what they've found, it's what they're planning next. And it reminded the world that the moon still holds secrets. That could explain why China hasn't shared much. If they found helium-3 in high concentration, it would give them a massive head start. It's not just interesting, it's inconsistent with everything we expect. Well, keeping the world guessing still works in their favor. That's important because the far side is shielded from Earth's radio signals. It's quiet, isolated. If you wanted to study something without being overheard, that's where you'd go. For weeks, China said almost nothing. The rover stopped to study the object. But then, silence. The outside world didn't get photos, no detailed scientific data. Again, there's no proof, but the location, the silence, and the language used by Chinese officials keep the questions alive. If this happened recently, the glass could still look shiny and different from its surroundings. That is what some scientists believe. U-2 found a patch of melted lunar material created by a past impact. That silence led to speculation. Eventually, a photo was released weeks after the discovery. The image wasn't clear. It was low resolution and taken at a distance. Let's walk through the possible explanations. First theory. Lunar impact glass. When a meteor hits the moon, it creates extreme heat and pressure that can melt the surface rock and form a kind of glass. It's plausible. Second theory. Something buried, then exposed. Some researchers suggest that what U-2 saw wasn't on the surface, it had been dug up by a small impact or natural erosion. Third theory. Something unknown. This is where things get speculative. Some believe the object could be the result of past activities, something ancient, artificial, or even alien. Now, we're not saying aliens, but we are saying the unexplained deserves attention. And there's one detail that fuels the curiosity. Why did China hold back the data? Most space agencies share mission findings openly. It's possible that they didn't want to jump to conclusions. It's also possible they found more than they said. Some online communities point to another detail: their object was located on the far side of the moon. It's also where some theories place ancient alien structures, hidden deep in craters or beneath the soil. And here's something else to consider. Since that 2019 discovery, U-22 has made other finds: odd rock formations, unusual soil behavior, and strange temperature readings. Some speculated might contain high levels of helium-3, and if they didn't, either way, the shiny patch is now part of moon mystery lore. It might be glass. It might be something stranger. In the next chapter, we'll explore China's long-term strategy. Chapter 4: Lunar Base Plans and the Great Energy Race. If you've been following space news over the past few years, you've probably noticed a shift. For decades, the moon was mostly ignored. After the Apollo missions ended, it faded into the background of space exploration. But now, suddenly, it's front and center again. And China is leading that charge. Quietly, steadily, and very deliberately. At first glance, you might think these missions are just about national pride, proving that they can land rovers, send back photos, plant flags. But when you look deeper, the picture changes. What China is really building is a long-term strategy, not just to explore the moon, but to stay there, and not just for science, but for power. That ice can be turned into water for astronauts, split into hydrogen and oxygen for rocket fuel, and support life for long-term missions. Whoever controls the South Pole might control the key to a permanent lunar economy. Let's talk about the plan. But China's approach is different, more subtle, less focused on spectacle, more on stability. While NASA talks about astronauts walking on the moon again, China is laying cables, building communication relays, mapping the terrain, quietly putting pieces in place. That is perfect for solar energy, a critical factor if you're trying to power a base without fossil fuels or nuclear reactors. It's about energy dominance. China has already outlined a multi-decade roadmap to build a permanent presence on the moon. That's why China isn't rushing their lunar missions. They're surveying, scanning, planning, quietly assessing where the richest deposits are and how to extract them. A launch pad for future missions to Mars, to asteroids, maybe even to the outer planets. It's rare on Earth, but extremely abundant on the moon's surface, especially in regions with high solar exposure, like the South Pole. Some scientists estimate that a few tons of helium-3 could power an entire country for a year, without the risks of nuclear waste. China has declined to sign. Instead, it's building its own coalition, with countries like Russia, Venezuela, Pakistan, and several African partners expressing interest. Two competing visions of the future, both racing toward the same destination. This isn't science fiction. It's not vague. They've released detailed documents about what they call the International Lunar Research Station, or I. The goal is to create a modular, habitable base, possibly by the mid-2030s, located near the moon's south pole. Power stations designed to beam energy back to Earth. These are not just scientific tools. They're infrastructure for a lunar economy, and possibly a lunar defense system. Why the South Pole? Because that region is rich in two things: sunlight and resources. Others see it as the dawn of a new industrial revolution, one that starts not in factories, but in craters and dust fields. Because when you look at it all together, something becomes clear. This isn't just science anymore. It's strategy, and maybe it's already much further along than anyone expected. Either way, the shift is happening fast. Drones, lunar 3D printers, robotic arms, all designed to build and maintain lunar facilities without constant human presence. It's a long game, a machine-first approach. Humans will come later, once everything is set up. They're not just aiming to visit, they're aiming to own the future. Unlike the moon's equator, which goes through long, freezing nights, the South Pole has peaks that are almost constantly illuminated. But more importantly, this region is believed to contain deposits of ice, trapped in permanently shadowed craters. They've invited other nations to join their lunar base project, but the invitation comes with strings. Right now, no one officially owns the moon, but whoever sets up permanent operations first will likely set the norms, and that could shape everything, from mining rights to space traffic laws. It positions China, not the US, as the central hub of future moon exploration. And it's not just about cooperation, it's about leadership, about setting the rules, creating the standards, owning the infrastructure. Now, here's where it gets more intense. China is not planning to do this alone. The United States has its own program, NASA's Artemis, which also aims to return humans to the moon and establish a base, possibly by 2030. And behind all of it is Helium-3. As we mentioned earlier, Helium-3 is a non-radioactive isotope that could power future fusion reactors. That changes everything, because this isn't just about space exploration anymore. In a world struggling with climate change, fossil fuel shortages, and rising energy demands, the nation that figures out how to mine and use Helium-3 could reshape the global energy landscape. But here's something even more interesting. China is also investing in robotic infrastructure. Instead of sending large human crews, they're developing advanced autonomous systems. And if they succeed, they'll have something far more valuable than a few rocks or moonwalks. They'll have a functioning outpost, a power station in space. That brings us to the geopolitical side of things. Many experts now compare the moon to the Arctic Ocean, a place rich in resources, governed by vague international rules, and increasingly seen as a zone of strategic competition. The US has promoted the Artemis Accords, a framework for space exploration with an emphasis on transparency and cooperation. And in the middle of that race, we're starting to see moves that feel familiar. Satellite deployments that just happen to orbit lunar poles, communication arrays that could double as surveillance systems. Some worry this could turn space into the next battlefield. The moon is no longer just a rock in the sky. It's becoming a place of real estate, of resources, of rivalry, and China. In the final chapter, we'll connect all the dots, the secret mining signals, the mysterious shiny patch, the silent buildup of infrastructure. Chapter 5, What They Know and Why They're Not Telling Us. It starts with a silence, not the kind of silence that comes from not knowing, but the kind that comes when someone knows something and chooses not to speak. For years now, both the Chinese and American space agencies have sent probes, orbiters, and landers to the moon. They've mapped every crater, scanned the regolith, studied the light bouncing off its surface. The data collected is enormous, yet strangely, only fragments make it to the public. Carefully selected images, sanitized reports, scientific papers that say a lot without saying too much. And then there's the shiny patch. It was first detected by China's Change 4 lander, a strange, unusually reflective area on the far side of the moon. Not ice, not metal, something else. The official report called it gel-like. That was the word, gel-like material. But no samples, no follow-up images, no explanation. Just a curious anomaly, and media attention stumble on something so strange, and then simply move on. And then, radio's silence. Their lunar rover changed direction. Something about that location drew their attention. Quietly, methodically. But no one ever said why. Because China isn't just keeping quiet. They're building barriers. Digital ones. Their space data archives are increasingly locked behind government firewalls. Independent researchers report sudden restrictions. Collaborations quietly shut down. Even within China, access to raw mission data is being reduced. Why would one of the most ambitious space programs in the world, with all its equipment, expertise, no details, just that phrase, a breakthrough? Again, nothing further was made public. That China's lunar program is now being partially overseen by its Strategic Support Force, the branch responsible for cyber warfare, satellite operations, and space-based intelligence. Which raises the question, when did lunar exploration become a military interest? Unless they didn't, and if there are deposits concentrated in certain locations, maybe even in that shiny patch zone, then secrecy becomes a strategic necessity, not just to prevent rivals from catching up, but to buy time, to build, to claim, to secure. But remnants, traces, technologies lost to time, ancient collisions, forgotten processes, the kind of things that don't fit neatly into public reports, but demand serious attention behind closed doors, almost like a data packet. It didn't match any known transmission from Earth. areas where the lunar crust behaves oddly, inexplicable. What do? Do you announce it? Or do you quietly study it, build around it, prepare for what comes next, while the rest of the world is still watching Mars documentaries? Some scientists propose these could be remnants of ancient impacts, a race not to reach the moon, but to own it, to dominate its resources, to lock in first-mover advantage, and to make sure that when the world wakes up to what's really up there, it's already too late. Their mining prototypes are quietly being tested in Earth orbit, and their plans outlined in white papers no one reads, stretch decades into the future. It's about space positioning, economic, strategic, existential. It changes everything we thought we knew about the moon. And who really owns the future? Consider subscribing. There's a lot more hidden out there, and we'll be right here, uncovering it, one mystery at a time, and chose not to tell. Others suggest something deeper, something artificial. It came from the moon's far side, the same area where China had deployed its Kuiqiao relay satellite to maintain communications with Change 4. Because when you trace the movements of Chinese lunar missions after that, a pattern begins to form. They lingered longer in that region. They deployed new instruments, and that's not the only mystery. And maybe it is. In 2022, a strange signal was picked up by ground stations monitoring lunar frequencies, a short burst. Decades later, when that sample was written, tiny glass-like structures were found, containing trapped gases at high pressure. Something hard to explain without advanced processes. The findings were never widely publicized. The signal was never explained. But shortly after, Chinese scientists announced a breakthrough in remote sensing analysis. So we're left to wonder, what did they find? Now, here's where it gets more interesting. This isn't just bureaucracy, it's control. Tight control over something. Meanwhile, rumors have begun to leak, not from scientists, but from military analysts. Unless it always was. Let's talk about resources again. If helium-3 is even half as valuable as predicted, then controlling it could make any nation a superpower overnight. And it's not just helium-3. There are whispers, unconfirmed, speculative, but persistent, that China's probes have detected unusual magnetic anomalies in that region. Of course, that sounds like science fiction, but consider this. In 1976, the Soviet Union's Lunar 24 mission reportedly retrieved a soil sample from deep beneath the moon's surface, nearly 2 meters down. What if the moon isn't just a dead rock? What if there's more beneath the surface than we realize? Not aliens, not bases. It would explain the silence. Because if you're the first to find something truly paradigm-shifting, a new energy source, an unknown material, or even just evidence of something, it's no longer about space exploration. And the truth is, China might already be far ahead. Their rovers have traveled miles. Their satellites see the moon in wavelengths we don't use. So, why the silence? Because the game is on. The real one. The one not shown on live streams or science blogs. So next time you look up at the night sky, and you see the moon hanging there, cold and quiet, glowing softly above us all, remember this. Somewhere beneath that silver dust, machines might already be digging. Quietly, efficiently. Not for all of us, but for those who knew first. Maybe we'll never know the full story behind what's happening up there. Maybe we're not supposed to. But if even a part of this is true, if this story made you think, or feel just a bit more curious,